This video is about learning computer code. This is designed to be for absolute beginners, and by the end of this video you will know quite a bit about basic computer code, probably more than the average Joe. Now, the first thing you need to know about computer code generally, it's a very instructional based language. You don't really write a computer paragraph and say, oh yes, could you please go ahead and divide this number by this one. No, it's kind of like a calculator. You push the numbers, you push you determine the operations, and it gives you the result. And computer code is like this, only a lot fancier and a lot more complex. So, I'm going to be teaching you a particular computer language that is called Java. And a few of you curious computer code veterans who have decided to click on this video are probably saying, Java? What's wrong with this guy? And I'll be honest, Java, which is the code language I'm going to teach you, is not the best computer language in the world. It's not. But what I will say is that it is very, very, very similar to another language called C. And C is very good. Everyone loves C. Everyone uses C. You're probably thinking, well, why don't I teach you C? Well, Java is a little bit easier to understand. And it's going to be good for an absolute beginner, such as yourself. So the first thing that we need to understand within the world of computer code is we, first of all, write down a bunch of instructions. Write a bunch of things we want the computer to think about, and then we run the code. Now, I'm not going to go through exactly how something is run per se, but what it basically means is the computer feeds all of these instructions into the brain of the computer, which is known as the CPU, or the Central Processing Unit. And these instructions might produce certain outputs. For example, if your instruction was 3 plus 3 equals, and you gave it to your CPU would produce 6. So, I want you to get comfortable with this idea of you write down your instructions, you click a button, it goes through the CPU, and you get an output. Okay, so let's start with the most basic kind of element in the sphere of computing. It's called a variable. What is a variable? Well, the analogy that I like to use is, let's imagine a box. Let's say you are moving house. It's very exciting. You've got a box. The box is open. I'm not Picasso, you'll have to bear with me here. It's an open box. And there's space inside the box. Inside the box there is space. And let's give this box a name. Let's call it Boxy. Yes, very, very original. Now, let's say, as you're moving house, because that's the narrative that I've randomly chosen from the top of my head, you might put in just cutlery into Boxy, knives and poorly drawn forks and things. You put forks in here, or maybe instead you put furniture in here. I don't know. The point is that you have a box and you put things into the box, and the things that you put into the box are separate to the box. These forks are not boxies. They are not boxes themselves. They're forks, but they belong in the box. And you're probably sitting there thinking that was the most inane sentence anyone has ever spoken in their entire lives. Well, then you should understand variables quite well. We can actually have a variable, so I'm going to write for you a line of code. And generally, if you had some sort of environment set up, the lines would be labeled like this. I'm going to say Boxy equals 6. What does that mean? We have a thing. Think of it as a container, and it's just a box. It's like a label, if you will. And the value we have put into this box, the value we have attached to this label, is 6. So, the thing is, let's say later I was to write a line of code that looked like this. It said print Boxy +3. Now, for those of you who don't know, print means look at the brackets and put on screen the value inside the brackets. So if you ran this piece of code, right, Boxy equals 6, print Boxy +3, what's going to happen is you're going to feed these instructions into your CPU. Your CPU is going to say, okay, we have something called Boxy. Boxy is a number, it seems, with value 6. So, and then we want to put something onto the screen. So we're going to look at Boxy, and it remembers, it goes, well, we know that Boxy equals 6. So 6 +3, that's what we put onto the screen. And so on our computer monitor, after this code is run, we get 9 appearing on our screen. And of course, some of you Java veterans are yelling at your screens right now. The newbies have no idea what's going on, but the exactly what's going on, and they're furious. I have left out a few bits of information. First of all, in Java, this language, every line of code that you finish should end with a semicolon. And the reason that is because the CPU needs to know basically what each instruction is. And as far as we're concerned, this instruction is separate from that instruction. That's a terrible semicolon, by the way, but it's a semicolon. It's not a letter J. I'll fix it up. So that's the first thing, and the second thing is Java kind of gets confused when you just give it a word like this and you say box equals 6. You need to specify what type of box this is. And you need, in our case, to write the word int before here. So you're probably wondering, what is this? Well, int basically just means that we are giving Boxy a type, which is an integer. And you're thinking, whoa, what? There are types now? Yes. So basically, let's break this down, right? So in this line of code, we are declaring a variable. We are basically saying this variable exists. So what's going on here? Well, first, we have our type, which in our case is integer, which means they are whole numbers like -2 or 0 or 6 in our case. So this is the type of number of variable that we're using, and we can look at other types in a second. Then we have our variable name, what we're calling our box, and then we have the value that we're putting inside of a box. So I'm going to ask you to do something for me. Let's say I wanted to make I wanted to declare another variable. I wanted to call it cup. I wanted this to be an integer, and I wanted it to have a value of 3. How would I write that out? Well, it would simply be int cup There we are. We have declared a variable. So, and then we can use this label in other places, which is really cool. And you're probably sitting there wondering, well, why can't we just say print 6 plus 3 to produce 9 onto the screen? Why did we have to write Boxy? Well, when your variables get more and more complicated and all of a sudden you're dealing with big numbers with, lots of decimal places, not a lot of numbers after the decimal place and things like that, it's going to be very, very painful to write out all of those numbers every time, and it's very easy to just refer to a few letters. So, okay, we've got our variable. So what are some other types that we can have? Well, other types that we can have are, for instance, a character. And a character is basically something you see on the keyboard. So So if I was to declare a character, I wanted to call this variable name, and this character had a value of f. How would that look like? Because that seems a little scary. Well, let's go through it. Let's break it down. So we have our type. That comes first. Our type is character. We have our variable, which confusingly I've called name. And then we have our value, which is f. So I've said it follows the exact same formula as here and as here. Type, variable name, which is name, and then value, that's the value. Now unfortunately, this is where some of you get a little bit creative and a little bit naughty, and you start saying, well, what if I made, let's say, a character of that way, and I called my variable, I don't know, Bob, and I gave that a value of 9. Aha, because 9 is on my keyboard. What happens now? Well, that's fine. You can do that. That is a legal thing. You're not breaking any laws. That's absolutely fine. Some might be worried about that. And the interesting thing is that when you declare something of type integer, and it recognizes this as a number, you can do arithmetic. You can plus this or minus this with another variable like we saw here, divide, multiply, and all the rest of it, because it's an integer. But when you declare something as a character, it sees this the same way it sees this. Now, what's f plus 9? Well, some of you might get a bit creative and start counting on the alphabet, but the reality is, there is no such thing as f plus 9. It's apples and oranges. You cannot add numbers to a letter. 9 is a perfectly acceptable character, but because we're looking at it as a character and not a number, you can't do arithmetic with this. So Bob divided by 3 breaks the computer. It doesn't break the computer, but the computer gets very, very angry and it says, you can't do that. That's very bad. We're going to build an error because that's wrong. Cannot be done. That sort of thing. And we also have another type, and this is the last type I'll give you, so you'll have 3 types by the end of this video. You've also got strings. And a string is to say it's a type which represents a series of characters. A series of characters. So for instance, your string, let's have a look. Your string, it's same thing, right? Type, variable name, value. So we've got type, string. The variable name would be, that's a P by the way, player equals, and we need double quotations for this. Cool boy. There we go. So with this you can do all sorts of cool things with strings. We won't really get into that. And again, some of the veterans are angry at me again, because when you declare a character, you need single quotations around the I think we've done a lot of good work with introducing you to variables. But we haven't really done too much computation yet. I mean, we've sort of done this. But I'm going to be introducing you next time to something called conditional statements, which basically means we're going to look at variables and other things, and if they have certain characteristics, we're going to do this, but if they have other characteristics, we're going to do something else, which is very, very interesting. Or heck, if this video does really poorly and nobody wants that, we won't make the video, but we'll see how it goes. Thanks for watching. Have a good night.